And technically that's not an allowable reason, but I'm gonna let you go because we can discuss it beforehand. So who's absent?
Adeline.
Adeline,
Yeah, I
thank
haven't
you.
been here in a while. It was San or Cypress.
He doesn't need to know.
Appreciate
It's
it.
hot in here.
Okay.
Oh,
That's
it's
what
fine.
Lily's.
Alright. So yes, do you want to do the homework first or you want to finish the notes first?
I think we finished the homework.
Homework.
We'll do homework first.
I just like homework so it was like a nice bit together.
Okay.
Easy in the class.
Easy. We got it. Okay, ready? My last class angered me. This is my mood. Read it. I'm ready. We get a lunch break.
Oh, yeah.
Yeah.
Oh, yes, it's Thursdays, guys.
So hopefully I can turn it around, but it did not make me happy. I've now lost one of my pens. Whatever.
Just bring chicken nuggets.
Okay, here we go. So question number 1. In triangle MA, MT is the perpendicular bisector of AH. How many things can I mark when it tells me it's a perpendicular bisector? 2.
But then it's a third.
I can mark 90-degree angles, and I can mark congruent pieces. Now, I can also mark this.
Angle side angle.
Yeah.
Or angle side.
No. Okay, slow down. Just let me lead.
Oh, side angle side.
Let me lead.
I'm sorry.
Shut up. Okay. Can we now say the triangles are congruent?
Yes, we can.
Yes. So, by side angle side, can we now go like this, and this, and this?
Yeah.
Yes. So now, because it's a perpendicular bisector, that's all I needed to know. So now, which is not always true? What do you guys think it is? How many people have an answer? Let's check it out then. Is MAH an isosceles?
Yes, it is.
Guaranteed. So this is always true. Always. Is MAT isosceles?
No.
Do we know if this is equal to that?
No.
We don't know. So now, that will be the correct answer to the question.
Oh, yeah.
Okay? Just keeping it real. Okay. Does MT bisect AMH?
Yeah.
Yeah, that's what an angle bisector is. AMH, MT. So this is always true. The last one I can totally admit. How many of you chose 4 because you didn't understand it?
Josh was for it.
Yes. Okay. So yeah, maybe because you were like down to a 50-50. Does that make sense? Like that this is the problem, right? We got to understand what's going on. So I have a thing with too many markings on it. I'm just going to go over here and redraw. Feel free to redraw if you'd like. You know that that's 90 degrees, right? And you know that this angle has to equal that angle, and it's a acute angle. Let's say this angle is 40 degrees. Okay? Let's say this angle has to be 40 degrees, right? Do we know what this angle needs to be?
Yeah.
Because it's a right triangle, right? So what does this angle have to be?
50.
So right, 40 plus 50 is 90, and we've got the other 90, right? Does everybody agree this is going to be 50?
Yeah.
And that this has to be 50. Okay, so now, here we go. Is angle A and angle TMH complementary?
Yeah.
Is 40 plus 50 equal to 90?
Yeah.
Okay, so with using a numerical example, right? Or even just knowing if these two things are the same, and like if these two things are complementary, then these two things are complementary, right? Okay, so I would say this is a medium level question about a perpendicular bisector. Medium. Let's go to the next one. So did you notice I gave you 3 questions about perpendicular bisector? Guess what's going to be on your quiz?
Perpendicular bisector.
Just one though, okay? Okay, here we go. Now the next one, you had to draw a picture. Did everybody draw a picture?
Yep.
Okay, here we go. It says triangle ABC. Now you can't put the letters down until you get the next part of the statement. BD is the perpendicular bisector. So because they tell me the triangle is ABC, B has to be here so D can be here, right? Doesn't matter where I put A and C. But I can now mark 90 degrees and these are congruent. So, oh my gosh. Do we have the same exact picture essentially as from above?
Yeah.
Yes, okay, great. Now, here we go. Do we know what a median is?
Yeah.
It's in the middle. So does BD go to the midpoint of AC and to the vertex on the opposite side?
Yeah.
Yes. So this is a median. It is an altitude, right? I'm just going to go through here. It's a perpendicular bisector and it's an angle bisector. It's all the things, isn't it?
Yeah.
Perpendicular bisectors are all the things. So, which can be proven? Yes, it can be proven. Check. Hey, BD bisects angle ABC.
Correct.
Check. Triangle ABC is isosceles. Check. Right? So, is it going to be 1, 2, 3, or 4?
It's gonna be 4.
Because it can prove all things.
Yes, it can.
Okay? That one is definitely a higher level question because you have to know. And like this, like as soon as you're like, wait, I'm not sure about this one, and you're like, you're sure about 2 and 3, you know, makes it a little bit yucky. Okay, now this one. So first of all, it tells me that we just have a quadrilateral, right? And that quadrilateral, we have DE is the perpendicular bisector of AB. Which line is getting chopped in half? AB. So this is equal to that. And this is my perpendicular side. Now, there's a lot of other cool things that are going on, but I do not know anything about the length of DE. I don't know if DE is chopped in half. I know nothing. So, which statement is always true? Well, let's just go with what we've already talked about. We know that these two triangles are congruent. Do you guys agree with that? And then we actually do know, because if this side and this is a right angle, or, do you know what I mean? Like, these triangles are congruent to each other, but are the green triangles congruent to the blue triangles? We have no idea. And I want to just quickly show you how I can demonstrate that to you very easily. Here is AB. And I'm going to put C in the middle. This is the one that's cut in half. I know that this triangle is going to be congruent to that triangle. I know that this triangle is going to be congruent to that triangle. But can you guys clearly tell the bottom two triangles are not congruent to the top two triangles? So anything that, and so this is point E down here. This is actually officially called a kite. It's a quadrilateral that's called a kite. We don't do further study on a kite, but doesn't it look like a kite, right? The traditional kite with its tail. So it's officially called a kite. And kites are kind of cool. So why are kites cool? Because their diagonals are perpendicular. Because this angle is bisected, and actually this angle, it's not, those aren't equal angles, but this angle is also bisected, right? And then we actually do have two angles that, hey, jerk face, we have two angles that are congruent. This whole angle is equal to that whole angle. Do you see that?
Yeah.
So like there's an isosceles triangle on top and there's an isosceles triangle on the bottom, right? Do you see all that stuff that's happening in there? It's a pretty wild and crazy picture. But what that does help us do now with a more obnoxious picture, it helps us examine this stuff, right? Yes, sir.
We have to add the third tick, or third line to
Thank you. Thank you. Yep.
You're welcome.
All right. So here we go.
And mark reflexive on C.
Yeah, whatever. Okay, so here we go. ADC, BDC. So I'm just going to focus really quick right here. D's. ADC, BDC. Oh, is that always true?
Yeah.
That is the one that's always true. So as soon as you get E involved with something that's involved with the upper triangle, DAC, you know it can't be true. All right? Because this, you guys can now see that this is smaller than this one, right? Yeah. And so, same thing here. These opposite sides are not congruent, but these sides are congruent. And, I mean, we can say that AE is congruent to BE, but they didn't ask us that, right? So that's something that always happens with a perpendicular bisector. Okay, cool. Are we good on these? Okay, let's turn the page. I don't necessarily want to go crazy writing these things out, so I'm going to talk, because we have other stuff to do, right? You either tried these proofs or you didn't, so let's look and see what you got. The givens were parallel lines, both sets, and AC. So this was kind of a little rough. AC is congruent to BD. So I think when you guys were leaving the room, I thought this was an addition one. Did you have to actually do addition on this? You didn't, because you already had the full side. So you already had that this line is congruent to this line. Does that make sense? If they had given you CD is congruent to AB, you would have done reflexive property and then added them together. So I'm sorry if I misled people on that. I will make sure you have an addition practice before your quiz. For the parallel lines, this set of parallel lines gives us A congruent to D, okay? The other set of parallel lines gives us this angle, ECA, congruent to this angle, okay? So, and it's the whole parallel lines make congruent alternate interior of angles, and then you would have been done by angle, side angle, okay? So I think it was given angle, angle, triangle congruence, 4 steps, okay? All right, so on the back was a little bit better conversation. Your test is not going to have an overlapping triangles, but it's always good to keep looking for them, correct? So hopefully, did everybody notice that we have triangle BAD, right?
Yeah, I wrote this separate.
And we have triangle CDA. And so then when you, hopefully this will work, cool. It's always nice when it works. When you pull these triangles off to the side, then when it says BD is congruent to AC, you can then mark that these are congruent, right? And then you have right angles here. And then it was a shared side, reflexive property. Okay. So let's talk about some things you would have had in your proof. Did people maybe put a line that said the right angles or perpendicular lines form congruent right angles, right? That would be something you would definitely do. The next thing is reflexive property, but then you have to analyze, can we do angle, side, side? Is that something we're allowed to do? No. So the beauty about the right triangle is now this is a hypotenuse and this is a leg. So you needed a step that said triangle BAD is a right triangle, triangle CDA is a right triangle, because they contain right angles, and then you could prove by HL. Okay, so you're not going to have the overlapping triangles on your quiz. Okay, I'm going to make sure, so is there going to be a perpendicular bisector question that's multiple choice on your quiz? Yes. Is there going to be proving 2 triangles congruent, maybe using a midpoint and alternate interior angles? Something like that, right? You know what I'm talking about? There's going to be some perpendicular, but it's not going to be, I don't think, I have to double check. I don't think it's HL. Okay, that part I can't make a guarantee. I would have to double check my quiz, right? I figured that we would just bump the quiz till Tuesday. Does that make the most sense so we have enough practice time in class?
Yeah.
Okay. If anybody knows they're not going to be here on Tuesday, they feel comfortable taking it Monday or want to come for like a lunch or something on Monday, you feel free to do that. But I want to make sure I give you enough practice that you feel like you can show me what you know. Okay? All right. So, are we ready to go to notes? Okay. We have 10 minutes. I think we can. This is probably one of our longer proofs. However, let's think about why we're doing this proof. And I don't know if you saw this on the joke on the back of the packet. Pretty funny. All right. This down here is saying it is one thing, but proving it is another. But this is. Do you understand that the chef is in jail? Right? They're like she's on the other side of the glass talking to whomever. So this is like a visit into jail. And she says, "Bad news. They found the proof in the pudding." Uh-huh. No, nobody's ever heard about the proof in the pudding saying before?
No.
No.
Are you the proof in the pudding? Or are you the pudding in the proof?
No. Okay, so here we go. So first of all, just make your big fat table with your straight edge. It's a saying, the proof is in the pudding. And let's just calmly enter the proof, and if we need to take a break midway, we will do that. So your quiz is probably, it's 2 proofs and 2 or 3 multiple choice, and that's it. That's it. You already know what one of the multiple choices is. Perpendicular bisector, right? Okay. Okay. So when I was working with some kids yesterday, and when I do things with CPCTC, or things that are, if it doesn't say triangle congruent to triangle, I like having a colored pencil on or something to work with that maybe isn't a highlighter, or I can find my end goal, right? Because do you guys see 4 triangles? All right, we have this triangle and this triangle, but we also have the bigger triangle and the other bigger triangle, right? Okay, so the reason why I want maybe a color pencil or something is I don't want to mark these congruent, but I want to see what my goal is. My goal is to get FG congruent to EG. So doing the bigger triangles isn't helpful, is it? No, I want to do the smaller triangles. So right now, I know that to be able to finish the proof with CPCTC, right? This is planning. I'm going to need to prove triangle, GEB is congruent to triangle GFD. Okay. I still don't know how I'm doing that, but I know that's the step above. So sometimes, once again, we like to think about these proofs being like a sandwich. I know the bottom layer of the sandwich, don't I? And I have the given, which is the top layer of the sandwich, and I actually have something that I almost can put in the sandwich. Okay, let's look at what they gave us. So they gave us that AB is congruent to CD. Then they gave me the full side. Do you guys agree it's the full side? Sometimes I do things like that if I have a full side. Or I use a highlighter. Or you have to kind of figure out how you're going to make sense of that in your head. I have full side congruent to full side. And then I have CE congruent to AF. Okay. So I'm now going to go back here to these triangles. Okay. Let's do some more planning. Do I see some angles that are automatically there? Right? Does everybody see our vertical angles? Okay. So I know there's vertical angles. So once again, I'm just kind of planning over here. I got an angle. Now, I know BC If I take away EC, right, can I get BE? I'll do three lines on that one. And I can do 3 lines on this one. So what's that called when we do the take away part? It's going to give us a side. It's going to give us the subtraction postulate, right? So once again, I'm just kind of planning. Okay, so now here we go. This is where things are. I can't use EG and FG, right? Because that's my end game. This says the word quadrilateral. But what does that shape actually look like? What was the point of this lesson? Go back a page. What was the point of this lesson? Parallelograms, right? Do you guys agree? So does this look like a parallelogram? Okay. So now let's just think about parallelograms for a second. They told me AB is congruent to CD, and I haven't used that information, right? But since this is equal to that, and the whole side is equal to the whole side, isn't that one of the ways we can say we have a parallelogram? Yeah. And then if we have parallel lines, can we get another set of angles? Yeah. Okay. So we have a plan. It's not an easy plan, right? Remember, this is like the end of this unit. You're taking it pretty far. But we can all do vertical, and I think we can all see subtraction, right? Does everybody see subtraction? Well, I'll make sure I demonstrate it again, okay? All right, so let's get the given in here. Let's see. A, B, C, D. Then I have AD is congruent to BC. I just wrote it backwards though. Okay. So because I know lunch is coming up, let's take care of the subtraction part first to make sure everybody understands it. I'm going to throw a shoe at you. Okay. Be quiet. The deal is this. Right now we know that that yellow is congruent to yellow, right? So just pretend those are 10 long. Just pretend in your head. You don't have to do it. Then we know that EC is congruent to AF. Let's pretend those are 4. Isn't 10 subtract 4 6?
Yes.
You see? And 10 subtract 4 is 6. So BC subtract EC is BE. Remember how I would do, like, I would cross out the C's? So I have BE congruent to AD subtract AF, cross out the A's because that's the double letter, right? FD. Do you see it now? Thank you. Doesn't matter if you put DF or FD. Okay, so you can always do that. Like if you, like I scratched out here, you could always do that work off to the side. Yes.
We're gonna work on addition.
Yes, we can show addition. I can definitely just throw up some examples and I can work on that. That's a nice way. Like you guys leave total lunch, I can show you pictures and givens that require addition, givens and pictures that require subtraction. Okay, I'll do that for you. Okay, here we go. So this was subtraction postulate. Okay. Why don't you guys all try to put your vertical angles in before we leave? Does that sound fair? Everybody should be able to do that independently. Okay, do your vertical angles, please. And then you should be able to head out for lunch. And please don't disturb somebody that's still working on their vertical angles. You have to say vertical angles are congruent. Yep. DGF. There we go. Everybody deserves clean water. All right, friends. So I had some good conversations with people going in, people going out. So does vertical angles and reflexive have to be the first thing you do? No, but we always try to make sure everybody remembers to do that stuff. Second, I have some more stuff about subtraction. In addition, we'll get to that. So we're at this place where right now in our proof, let's see, subtraction postulate gave us a set of the set of sides. Vertical angles gives us a set of angles. And now we're to the place of, and this is a really important idea in proof and like just in general, we have used this information completely. We haven't used this information at all, right? So they're not going to give you information that you're not going to use. So the most popular way to tell somebody they have a parallelogram is the one set of sides that's both congruent and parallel. This is probably the next, there's the top three. So here we go. We need a parallelogram so we can talk about angles and parallel lines. So here we go. Is it A, B, C, D? Yeah. A, B, C, D is a parallelogram. So that funny little symbol, which I don't draw very well, but as long as you put a P in a box, everybody knows. Okay? A, B, C, D is a parallelogram. And so now let's say why. We started off with a quadrilateral, right? What does this quadrilateral have? Both pairs of opposite sides congruent, right? Both pairs, a quad with both pairs of opposite sides congruent is a parallelogram. So I've literally just said what I have. All right, but now this is where the gold is, right? Because now we can do those alternate interior Z angles. So before we can say that those angles are congruent, we just have to say that we have parallel lines. So if I want to make the letter Z, I want this guy to be parallel with that guy, right? Does everybody see how that works? And you actually could use like this is your transversal or that is your transversal. Does everybody see the backwards Z here? Right? So it doesn't matter which pair of angles you choose, but we have to have those lines be parallel next. Okay, so BC is parallel to AD. BC is parallel to AD because opposite sides are parallel in a parallelogram. Or, well, that should be a parallel. There we go. You could say in a parallelogram, opposite sides are parallel. Opposite sides of a parallelogram are parallel. Right? 1,000 different ways to say that sentence. Okay, now I just have to choose a pair of angles to use. I saw the diagonal one first, so I'm going to use.
Interrupt. Do I have to do the other side of parallel lines before I do the C's?
You have to have parallel lines to be able to say.
I'm saying the second pair, so like both pairs.
So we don't need both pairs. So a couple things. Sorry. If you've said lines are parallel, you're done with that. Do we need the other set of lines to be parallel for anything right now? So I'm just clarifying. So we don't need the other set of parallel lines. If this is in here, it's in here for all of the rest of the proof.
Okay.
So you don't need to state this twice.
Yeah, I just didn't know if like the other pair.
No. Okay. And I don't need the other pair because I only need one more set of angles. So I'm trying, yeah. So I'm going to use this angle and this angle if everybody's cool with that. Does everybody see where it comes from? Okay, so my first angle is angle EBG. Write that down. Angle EBG is congruent to angle FDG. I think I got that right. So parallel lines make congruent alternate interior angles. Okay, so we have our last set of angles, right? So are we ready to say our triangles are congruent? Yep. So it's 7 and 8, right? So you already knew, you didn't know it was step 8, but you knew the last step was going to be CPCTC, right? And you knew that you were going to be doing the triangles that we talked about there. So then this one is, I forget all the things at the top. I'll get it. Okay, so triangle JEB and GFD. GFD. So these guys are congruent, and I don't remember why, but I'm going to get there. And then it's FGEG. There we go. FG is congruent to EG. Okay, so I've got that. I still have to get my triangle reason. I didn't look carefully at the pictures. Yes, sir.
Do you want me to say it?
Nope.
Okay, sounds good. I'll let someone else say it.
Okay. All right. Can I scroll back up to the top? People
Yeah.
okay? Okay. So I need to go back up to the top because I did all this work. I have no idea what's up there anymore. So we did. Oh, okay. So the only thing we need to check. Ready? I have angle and angle. Are we doing the side between the angles? No. So it's going to be angle, angle, side, right? So that's the only thing I had to check. I knew it was going to be either angle, or angle, angle, side. Just checking angle, angle, side. And that's done.
Wait, you have to use step 8. You have to say that?
So you have to do step 8 because that was the goal of the proof, right? Okay. So on your quiz, I'm only asking you to prove triangles. You're not actually going to have to do, I don't think, I need to double check things. I'm not having you end a proof with CPCTC. I don't even think you have to use CPCTC, okay? So let's just pause and think about like the goals of this unit. Everybody should be able to tell which stuff works to make triangles congruent, right? The 5 different ways. Everyone should be able to know what a perpendicular bisector does, right? Reflexive property, vertical angles, yes? Then let's think about midpoints divide segments, angle bisectors divide angles, right? And then parallel lines most often are alternate interior angles. Addition and subtraction. Okay, so if you think about your flashcards, guys, right? I think you have like 12 flashcards. You're not going to be able to use every single one in every proof, right? Does that make sense, though? But you can kind of think, Ms. Rupp, we talked about these parallel lines. She's been talking about addition and subtraction a lot. There might be a bisect of something. I know I have a multiple choice on perpendicular bisector. Okay? All right. So this is what I have a worksheet that's a front and back that we can use in multiple different ways. We can actually write proofs for it, but it has some addition and subtraction examples, which is what somebody wanted. We still have all of Monday to practice. Agreed? Okay. So are we okay with, I'm going to give you a worksheet. You can do as much or as little as you want with it, but I want to do some of it together right now. Okay. I know it's a lot of me talking. Is everybody still okay with this? Because I know my voice is just so lovely. Lovely. Should I do it in an English accent? Would that make it better? I don't even know if that's an English accent. It's just some weird accent, lady. I could be like, gotta go park your car. No. Park your car and have a yard. 1, 2, 3, 4. And then it's like the way, I know bad movie lines and different accents. I probably should not do that, right?
There's your worksheet.
Okay, here's one for you. Here's one for you. Okay.
Look at the first one there.
Well, okay, so there's, yeah. What the? Yeah, go ahead. Yeah. Down? Yeah. Okay, I think I put this, let me make sure I can get this guy up on the board. I think I did. Regis questions perpendicular. No, that's not what I want. No. No. Okay, hold on. I know I made
You did good.
the thing, I think I just need, okay, can I change? Okay, so folks, I'm not actually asking you to do these proofs. We had some questions about, once again, it's all about digesting givens and seeing what you can do with the picture and what you have to do in words, okay? So I know, the one on the back is Crazy Town. But I put it on there for a reason, cause someday you see some Crazy Town. Someday, am I gonna force you to be perfect at Crazy Town? This is not Squid Games. You do not have to do this to survive. Do we understand?
If it was,
You want Squid Game, Miss Rob?
Okay, hold on. Do I watch Squid Games?
Squid Games is tough.
Squid Games is tough. Where is my document though that I
Have you watched
just
Squid Game,
downloaded?
Miss Rob?
Have I watched it before?
Yeah.
Yes. I've only seen like things that are like mockeries of it.
Making a USA version of it.
USA version.
They're making
USA version of
Addition and
What are you
subtraction.
talking about?
You didn't hear about it?
Okay, it's gonna be all right, guys. It's gonna be all right.
What, the one
Miss
with
Ruff
the
is all
beef?
confused. There we go. Let me just open this and then open it in Cami, and that way I can draw on it. Cami. Okay, here we go. So, okay, you're in charge. Addition or subtraction? What do we need to talk about first? Okay, addition. Turn to the back.
Thank you, Brandon, for the suggestion.
Okay, so go to the bottom one. Okay, go to the one on the bottom. Just don't look at the top. Hold the paper in hand. Do what you have to do with it. Making you cray.
Oh, we're not looking at the picture?
We're looking at this problem right here, right now.
Oh.
We're starting on that one. Please understand that I spent my lunch doing about 8 different things. This was one, and I haven't eaten lunch yet. Okay, so here we go. GH is congruent to LM. Mark it. GH is congruent to LM. Why are we happy about that? Because it's a set of sides. So I'm just going to put a little s here. Then it says HK is congruent to MJ. Ooh, why am I excited about that? That's a set of sides. Now, this is where we get to the end. I know Michael Jackson. So GJ, Michael Jordan, true, is congruent to KL or LK. Now, is from here to here the full length of this side of the triangle? No. So we're missing a piece, right? So while in our given would be GJ is congruent to LK, right? So this is given. Then I would have a line in my proof that has reflexive property, right? It would be JK is congruent to JK. I am not caring about the order of the letters. This is reflexive. Okay. This side, the J's cancel. Agreed? This side, the K's cancel. So now I have GK is congruent to LJ. So now, and you say addition, postulate, POST. So now, after I've written that all down, now I'm just going to take a moment to look back at my picture. GK, GK, GK. Is that a side of my triangle? Okay. LJ, LJ, LJ. This is my set of sides, right? So I can prove my triangle is congruent. Okay, so let's look at crazy addition up above it with those crazy triangles, right? Okay, so now I would never give you the proof above. But if I were to just give you delta math without picking out the problems, this picture could show up and you guys would all cry. Agreed?
No, we don't have that.
Yes.
Oh, I would
Yes.
cry.
Miss Robbie said we don't
I know.
have
I'm ready. I'm busting your chops right now. Here we go. Pause. So What are we given? What are we given?
That triangle ABH.
It's congruent.
Yeah, so find it. ABH is congruent to EDI, which means after the given, could you do CPCTC
Yes, we can, Miss.
like 95 times?
You
No,
put
not-
CP.
I know I did, dude. Give me a hot second.
Okay.
Right? Essentially times 6, right? Because there's 6 parts. Now, let's see what else they gave us. GHF is congruent to GIF. Okay, great. So could I do another CPCTC, whatever it is? I wouldn't necessarily do it 6 times because I'm going to come up with a plan, right? But do we agree that I'm going to need some of these parts? What is our end goal for this proof? Let's find it. We're trying to prove that BGC is congruent to DGC. I know, I got colors all around here. It's all good. So like I said, this proof has got a lot of cray-cray in it, but we're focusing on why would I need the addition postulate. Are you right? Right? So by CPCTC, for this triangle, can I say BH is congruent to ID? Do you guys agree with that?
Yeah.
Okay.
What would be the reason? 'Cause it's
CPCTC, right? Okay. Then, could I also say, for the other set of triangles, this side is congruent to that side, right? So that's going to be GH is congruent to GI by CPCTC. If I add those together, don't I get a side of this triangle? And if I add these two together, I get a side of the triangle, right? So the H's cancel out. BG is that side on the left is congruent to, yeah. And that's the addition postulate. Now, that is some super cray-cray. But now that we did that, you don't write anything down, just watch the process. Does everybody agree that we could use CPCTC to say that angle is congruent to that angle?
Mhm.
Could we make a big fat X here? Does everybody see side, angle, side? And that's the proof. See what I mean? So yes, these things are scary. Life is scary. You just got to take a deep breath. Okay, so let's flip to the other side. So those are some examples of addition. Let's look at some examples of subtraction. Okay. So let's do this one up here. I found this, but I didn't like the givens they had with it. So let's pretend that you were given AD is congruent to CE. Okay, so write that part down. And then our goal is to prove triangle ABE is congruent to triangle CBD. Okay. So the triangles we want to prove are these guys on the outside, right? You see them? And this is definitely, like, the way the markings are right now, this would never work because right now there's like not enough. Actually, there's something, but shut up. Okay, shut up. Okay. Right? Do you guys agree AD is too long? Do you guys agree that's too long?
Yeah.
Okay. And do you agree that CE is too long? But they overlap, right? So I can do reflexive property. I would say ED is congruent to ED by reflexive. I'm just writing reflex because I ran out of paper. And then what's going to cancel? The D's cancel on this side, leaving me with AE. And the E's cancel on this side, leaving me with CD by subtraction. And now I get this guy congruent to that guy. So what I was noticing in my head as we were having that conversation is as it's marked right now, do you guys see angle side side, which is not legit, right? But what kind of triangle is triangle ABC? The big triangle. Ah, so if two angles are congruent, then the base angles are congruent. Ah! Like it gets really messy, right? But isn't that true? When we have two sides congruent, we got the base angles congruent? Yeah, so then we would have side angle side or angle side angle. Like we could do all sorts of things, right? So I just pulled that picture because it was a picture that worked for this conversation. Okay. All right. Are we feeling okay a little bit more about this idea now? Okay. No? No, maybe, maybe not. So the bottom one is kind of, the bottom one has the given and the way you were supposed to go. And like, so this one is, I would have some right angles. Let's just look at it. Do you guys see right angles here? So that would be a right angle. That would be a right angle. They gave me those ends, A, B, and E, F are congruent, but then they gave me, here it is, too long, B, D, right? Too long. C, E. So do you see how you would subtract? And then this guy's equal to that guy, and this is side angle side, not HL, right? Side angle side. Side angle side. Okay. Meditative process. Would you guys like an opportunity for some like bonus points?
Yes, I would.
Okay, so this is what we're gonna do. I'm gonna go, so should you like kind of look through your notes maybe or your flashcards this weekend? Once again, you kind of have the idea of what things you need to know. I don't have your review packet. I can post it online when I get it ready, but you'll definitely have it on Monday. It's 4 questions, five. I'm gonna say 5. Because the first question is so easy, it makes me cry. This is what I'm gonna do for your bonus. Ready? But you kind of have to, ready? Don't cheat for somebody else. That would be rude, right? In here, okay, so this is called the Triangle Congruence Escape Room. Edit. Edit. I need to actually assign it. Due date. When do we want to have it be due?
Wednesday.
Wednesday?
Tuesday.
How about by Sunday
Okay.
of the following week?
Oh, that's a long time.
It is a long time. Am I being nice?
Yes, very
Okay,
nice.
this is the deal. So let me quickly explain this to you. Let me just assign and assign it. Yeah, you're gonna see it. Okay, so this is how this thing works. It's like you might want a piece of paper with you while you're working on it. You guys have done like the escape room / like the boxes.
We were gonna do escape room.
Okay, so
Shh. I was trying to fell apart.
So you put your name down here. There are 4 suspects: Annie Angle, Sam Sides, this person, Riley Reflex, and H Leg.
That was not the
And literally after you put your name, I'm just going to do this really for a first part. Do you see how you have something to read? And then you have little activities to do. And it'll tell you if you're wrong and not let you go forward. Does that make, and not, ready? It doesn't go past, I think, like, angle side, you know what I mean? Like, it's not asking you to do a proof. Does that make sense to everybody? It's an activity to review. So if you want the points, do the activity. At the end, it will ask you to narrow it down as to who's not, who's not the person. who's not the person, who's not the person. So I think there's three or four sets. Okay? Have some fun with it. Don't cheat for somebody else. You got me? You can ask for help, but don't do it for somebody else. Does that make sense? Please be nice.
No, Amir, I'm not doing it free.
You have a whole lot of time. Oh, my Lanta.
Hey, guess what?
And it's go through, it's, you know, it's not this, it's hookah again.
I feel like that's what I'm